Okay, AP Stats, here we go with section 5.1, day 2. We're really pushing this idea that probability can be thought of as long-term rate of success or long-term rate of failure or long-term results turned into numbers. We will learn some theoretical probability formulas that'll help us find a theoretical probability, but right now in section 5.1, what happens in the long run? Okay, so until we learn all of the theoretical rules of probability enough to answer certain kind of questions, the only way we can address a difficult probability question is to estimate the probability by keeping track of observations. Now, frequently, we don't have time to wait around, a whole bunch of days to see if it rains when there's a 30% chance of rain and keep track of all of them. What we do is we will use simulated trials. Right? So we could start now and then wait until there are 30% chance of rain days and see what happens. Or we could do this. I'm going to do math, a probability. I'm going to do a random integer. Ready for this? I'm going to go from 0 to 9. Oops. No, I'm not. I did that wrong. I'm going to go from 0 to 9. That's 10 digits. If it's a 0, 1, or 2, it rains. If it's a 3, 4, 5, 6, 7, 8, or 9, it doesn't rain. I'm just going to do one of them. Ready? It didn't rain. That's a lot faster than waiting all day to see if it rains. Want me to do it again? Instead of waiting 2 days, I just do there's 2 days where it didn't rain. Let me do it a third day. There's 3 days where it didn't rain. That time it did rain. 1 out of 4. See what I mean? Okay. Simulated trials is a much quicker way to go through than an actual trial. But the trick is picking numbers like 0, 1, and 2 represent it rains, and 3 through 9 represents that it doesn't rain. That's really the trick. And then figuring out how many times I should do this. Okay, a simple example of this is flipping the coins yesterday. And then not the one where you guys made stuff up. I'm talking about this one from yesterday. I flipped a coin 20 times. I mean, I used my calculator, I think, but I flipped 20 times. Now, how many heads did I get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 heads. Flipping coins yesterday, you look to find the probability of heads, which means how often does heads come up? What's the probability when I flip a coin that I get heads? That's the probability of having heads turn up when you flip the coin once. So what happened is you got 12 out of 20 flips, which is a proportion of 60% or 0.60. Really, that's our estimate from yesterday for the probability of heads. But we actually know in theory that it's not 60%. We know in theory that the probability of heads is equal to 0.50 because it's such a simple thing. It's a success or a failure, and they're equally likely. That's not always the case, that it's success or failure and they're equally likely. For example, if there's a 30% chance of it raining, there's a 30% chance of success, but a 70% chance of failure. That's not like flipping a coin. For this one, we don't really need an estimate for the probability of H. We just kind of went through that activity so that you guys could start to see in the short term, we're completely unpredictable. This isn't even the long term yet, and it's already starting to even out a little bit. Here's an example that would definitely require estimation because it's not as easy as heads or tails and equally likely. It's also not as equally as 30% chance of rain and 70% chance that it doesn't rain. A Cubs player has a career batting average of .325. But he went through a rough stretch this past season. In 1 week, he played 6 games, had 20 at-bats. He didn't take any walks and only got 4 hits. So that's 4 out of 20. The Cubs are talking about trading him. Just to get an idea of how good or bad this week was, find the probability that the number of successes would be 4 or less. It's not just 4, but 4 or less, which means the probability that this hitter would get 4 or less hits out of 20 when his batting average is .325. Just think about that for a second. What's the probability that somebody who bats .325 would go 4 for 20 or less? That's not an easy question to answer. So we will actually be able to find the theoretical probability for that kind of problem using formulas that we will learn in this chapter and the next one, and even functions on the calculator that will make this kind of stuff easy. At the end of the notes, if I remember, I'll show you what that actual probability is. Okay, for now, we need to describe how to come up with a legitimate estimate using simulation. This, by the way, for those of you guys planning or thinking about taking the AP exam, you can always answer a probability question with an estimate. Always. You design some kind of simulation, and you can always solve that kind of problem with a simulation. Okay, next page.